What is up, everybody? Mark here, joined by two of my friends, Mr. Ryan Muckenhirn, pretty much a staple around here, and repeat guest, Mr. Reuben Aleckson.
Yes, sir.
Now, Reuben, I'm going to preface this. We talk a lot about extending your effective range, long range shooting, ballistic calculators. Reuben, and we were talking about getting some ballistic data the other day. And one thing that we were talking about, and one thing that you need to plug into your ballistic calculator, is the BC, the ballistic coefficient. But there's more than one. And even your calculator will make you select, you got to pick. And then I always thought it was either G1 or G7, which I think I've actually been mistakenly using the G1 occasionally. I got one of my printouts here. This is from the folks over at Kestrel, which we actually did a podcast with them at one time. So check that out. There's like 8. And then one was like marked GL. But I think what are the ones we need to concern ourselves with? Is it just the G1 and the G7?
We'll talk G1, G7. Some solvers have a custom curve.
Okay.
And then we've got multi-BC. So
that sounds like the one for me because I don't like to pick.
Oof. Within shooting. We'll talk about those probably primarily.
Okay. Reuben, what is a G1 BC? When does a person want to use that?
Well, I'm going to preface this by saying when we give this information, we're saying for most users, okay, in most applications. There's probably going to be exceptions here or there, but we want to select when we're inputting that in the calculator, whether that be in our Fury ABs or in our Razor 4000 GBs, right? We're going to have to pick something when we're selecting our bullet. We want to base that off of the shape of the bullet, right? So years ago, I thought you just pick the one that looks better. G1 is going to be a higher number typically, so let's go with that. I couldn't have been further from the truth, right? Because we want to pick it based on the shape of the bullet. So G1, if we're, again, kind of generalizing, G1 is going to be, we always say like the cartoon-shaped bullet, like the flat base bullet, typically shorter, and we've got a muzzleloader bullet up there. I believe that's a 50 cal. Ryan, you might know more about that bullet. But yeah, we've got a flat base and no boat tail, and not a super gradual taper on the ogive, right? So we can kind of look at that. And again, there might be exceptions, but a lot of time we think like pistol bullets, muzzleloader bullets, shotgun slugs, but we could even go into bullets like a Hornady VMAX. Some of those are flat base, and a lot of traditional hunting bullets are probably a flat base. Whereas when we step into more the longer, sleeker, slippery, long-range bullets, a lot of times what we're going to see is we're going to see a boat tail. We're going to see a bullet that looks more efficient, more aerodynamic, flies through the air better.
I like it. Yeah, I mean, I think that's one of the big things is, and it's probably obvious by looking at the examples you hear, but the BC, I guess, denotes how efficiently that bullet passes through the air. Would that be correct?
Yeah, and so the reason why we kind of break it down into two main options, there's a G1 standard projectile. It's 1 inch in diameter, I believe 1 pound. And so how that weight is distributed kind of shows the shape of the bullet, and it kind of gives you an example of what a G1 standard projectile looks like. And there's a G7 standard as well. And so you could usually look at the shape of the bullet and be like, yep, that's a G1. We should compare it to how a G1 standard projectile looks, or that's a G7. We want to compare that. Now, the one thing that is, it's nice, it's because if you select the wrong one, it's not the end of the world, because inside of that, within that supersonic flight, you're going to get very similar numbers. Where we start to see more accurate numbers out of our ballistic solver is when we go into transonic and to subsonic. Really, through transonic is the biggest thing.
Okay, gotcha. Because that's one thing I was like, well, it hasn't, for whatever reason, I've just always plugged in a G1, and it hasn't not been working.
Right.
But then I'm like, obviously we're talking about precision here, so you want to make things as precise as possible. But I guess that maybe explains a little bit why, probably within the capabilities of myself and my equipment, haven't noticed like something being, I guess, grossly off.
Yeah, and you wouldn't also want to assume that if you're seeing numbers that don't agree with your solver's solution, you wouldn't want to instantly assume that you selected the wrong number, because you might have a bullet that's too heavy or too long for the twist rate of your rifle. You might just happen to have, a factory loading that doesn't shoot super great out of that gun. So don't instantly assume that, I should have picked this number instead of this number in the solver or in the calculator. But that can be one of the things that when you start to see discrepancies at longer ranges, especially kind of coming up on that leading edge of transonic, that can be coming from selecting the wrong number in your solver.
Gotcha. So what's happening, okay, do you know how ballistic coefficient is affecting things during that critical time, like as it goes from, supersonic to transonic, and then when it is transonic, why does it matter a lot then?
So air currents, if we look at that bullet, I can't remember what the imagery is, where you can see the air current moving over the bullet.
Mm-hmm.
The ballistic coefficient, the higher that value, the better it cuts air. Like, that's the whole point of ballistic coefficient, right? As we enter transonic or go through the transonic range into the subsonic range, the air current in front of the bullet begins to move down that bullet. Like instead of it being in front of the nose of the bullet and then following the ogive, starts moving back toward the shank of the bullet. The higher the ballistic coefficient, the better it handles that period.
Okay.
Yeah.
Yeah, it was kind of explained to me in the way my brain works. It kind of, the bullet's unsupported going through the transonic portion of the flight regime, right? And that regime, is where,
I like that.
Yeah, that's where you really want a bullet that's more stable. So twist rate can affect it. If you have a faster twist, as long as the bullet can handle it, it will mean the bullet's more stable through that period too. But the bullet is kind of kept in place per se by consistent pressure on the front and the back of the bullet as it's flying, right? And so higher BC, really don't get it too confused with like it's going to perform better when you hit an animal. A higher BC means that it's more aerodynamic, so better retained velocity and less wind deflection. Those two things will, and kind of when you said it earlier, extending your range, right? It might not necessarily be, it kind of affects other things that affect that, right? So more retained velocity means more energy, right? Which is going to push you a little bit farther. More retained velocity also might mean that you get a wider range band in having that bullet properly expand in the medium that you're hitting,
sure.
right?
Mm-hmm.
So a higher BC bullet doesn't necessarily mean that it hits harder, given all else equal. It just means that you're going to be able to have, better performance, less velocity degradation in that same amount of distance, and also retained energy because of that. And wind deflection, that's a big thing with BC.
Oh, yeah. Talk about that a little bit. Just, I guess it is what it is.
I mean, that's
so
kind of...
The slipperier that bullet is, the higher the ballistic coefficient is, the less affected during its flight path. How would you call it, the regime?
Good.
Okay, the less affected during its flight it is by these other forces. Gravity is a constant, wind is a variable, and the higher we can, or the easier we can pass through air unimpeded, the less deflection that we have, the more aerodynamically sound we are in that projectile's design, and the easier it is to make an impact at distance. Like Reuben was saying, if everything was kept equal and I was able to move that 320 grain bullet at the same velocity as I could this 140 grain bullet, just due to the profile itself, this thing, it has a huge cross section, so it's like a sail out there, right? It's getting pushed by wind, but it's also not cutting air as efficiently as this 140 grain ELD is. You're going to lose in drop, of course, and wind exponentially. And then to Reuben's point earlier about BC providing you a distinct advantage, not by itself anyways, from a terminal perspective, like these two bullets, I've got a 127 grain Barnes LRX and a 140 grain Hornady ELD. They're remarkably similar in size, shape, and profile, but they're wildly different in ballistic coefficient. I can get them to appreciably the same launch velocity. However, the Hornady, because of its much higher BC, is going to retain that velocity better. It's going to drop less and it's going to drift less in the wind. That bullet will expand at a given distance. Once we start getting around that 600, 700, 800, 900 yard range, much better than that Barnes will. Now, part of that is also bullet construction.
I was going to say,
well.
you got material composition
Correct,
there.
which is an aside. However, if we could increase the BC of a homogeneous bullet like that Barnes, and then carry velocity a longer distance, we could get reliable mechanical expansion out of it to potentially match that of the Hornady. We would have to defy bullet design principles, I think, to get there. And so these two would live then in very different spaces, right? So for me as a shooter and a user, like for many, 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 many years, and even recently and currently, I use a G1 profile in my ballistic solver and then validate my data, and by God, it's spot on. I'm not doing the kind of shooting that I would appreciate what the G7 would give me if I plug those numbers in there. To Reuben's point earlier, you're operating at distances generally hundreds of yards, possibly double the distance that I am, and that's where you really start to see that difference, right?
I would say when we get into, and kind of keeping it on the user level, when we start getting into why it really matters selecting the correct number is, like I said, transonic and beyond, and that is that's where a lot of people shoot long range. If you ever see somebody that wants to hit that 14, 15, 1600 yard target, and they've got a very accurate rifle and they've got a very consistent load with a good bullet, if you start to see discrepancies, that's where you would want to reference back and see if you selected all the right inputs using now I will say this too, just to backtrack a little bit. If you're shooting a G7 bullet, a G7 shaped bullet, doesn't hurt you to use the G7 profile
You're making your
in
data
solver.
more robust.
You're making your data more robust for longer distances. And sometimes you'll hear people say that the data from the G1 lines up better. It could be, but it's probably something to do with just validating and truing that data. I don't necessarily think that you would ever see where overall throughout the entire flight regime where it was better using the wrong number, right? Like say G1, because if we looked at it on a chart and we saw that drag profile or the BC, right? If we looked at that drag, there's kind of like this point where it starts down at lower Mach numbers or sub Mach 1, and it kind of drops, and then it will spike up about, and you'll see the BC go higher at that above Mach 1, above transonic. And then it kind of tails off, right? As we increase Mach numbers, the BC drops again on that chart. When you look at a chart, you can reference that by just looking up a ballistic coefficient chart, like G1 versus G7. You can see that. But a lot of times when people validate data, they validate at maybe one range, right? They'll come out and they'll say, I'm zeroed at this distance, I want to shoot at 500, and I want to shoot at 800. And you may see correlation where it lined up perfectly at that distance, and then your next truing distance, it lined up perfectly too. But then you might come back to 600 and be high or low. You might come back to 500 and be high or low. Or you might come back to 300 and be way high, something like that, right? So I think selecting the appropriate one based on the size or the shape of the bullet, what profile it has, you'll get better numbers all the way through different distances.
Gotcha.
But you might convince yourself that this one always lines up great because you might only validate at a couple of different distances, right?
Gotcha.
And then we mentioned it earlier, like multi-BC, that's something that you see in the Ballistic Solver that we've got on the Razor 4000 GB. Multi-BC basically comes in and says, at this Mach number, this is the bullet's recorded BC. At this Mach number, it's this. And it'll kind of apply that based on the bullet's velocity throughout that drop chart, right? When you look and you see all your data from 100 yards to 1,500 yards, it's applying the appropriate Mach number based on the bullet's velocity.
What are you using when you're using the GB?
I've used that.
Well, it depends on the bullet.
But I've used that multi-BC quite a bit with good results. I think more than anything, we get the opportunity to be on the range a lot, so we confirm and validate a lot of different stuff over time. And so kind of use what lines up best. And then since a lot of the shooting we do is 1,000 or beyond, just getting ready for some like PRS matches and stuff like that, we'll definitely make sure that our numbers line up out of distance. Usually what you're going to see is applying the appropriate BC based on the shape of the bullet. You'll see better correlation. But then within like the Fury ABs, our app has G1, G7, and custom curve. And what Applied Ballistics does in their software is they'll actually get bullets from the manufacturer, shoot them over radar, and validate the BC. And they often do that. So if you ever see an update is available pop up when you open your app, that's either a new bullet being added to the library or they're adding the latest data from that that specific bullet being shot over radar. I've used the custom curve a lot with really good results, but I think the biggest thing to know with all of this is that every rifle is different depending on the rifling in your barrel, depending on your crown, depending on the velocity you're shooting at. You may see slightly different numbers, and with the custom curve, if you are selecting that, you may end up going into the truing portion of the app and then just entering data, right? So it'll tell you, we want you to validate at 600 and we want you to validate at 1200. And then the more data points you can put in when you're validating, it'll apply that and adjust that, the actual BC number. But yeah, that's kind of what I do. I think just look at what works the best for that specific rifle and specific system. But I do think it is something to kind of pay attention to when you're going in and maybe stepping into long range shooting for the first time, and you want to take that cartridge out. And once we start to get where the velocity drops into that transonic, selecting the right number will really probably help you out to get good data in, good data out.
Boy, that is the truth, isn't it?
Yep.
You guys always talk about tolerance stacking, and that's one of them.
Oh yeah, especially with that custom curve thing, like Reuben was saying, just how your individual rifle imprints and engraves that projectile varies your BC.
Mm-hmm.
So
even taking that a step further, if you go to a precision match where Applied Ballistics is, they'll allow you to shoot your rifle with your bullets over radar, and then that's what you call a personal drag model. So they'll enter that into their database, and then you go into the app, and it's like the initials, the date that you shot, and the bullet type, and you can actually select your data, which is basically taking what your rifle does to the bullet through the process of pushing it out through the rifling, and then applies that out, extrapolates it out through the ranges you shoot.
We got pretty lucky when they were out here. Polly and I got our smokeless muzzleloaders custom dragged.
Yeah, no, I missed that day.
That was fun. We were shooting those two 1,050, and it made a really big difference to see. Like, we had published data for the projectile from the projectile manufacturer, and it was definitely different when fired from the gun. And using the published data, I'm not saying that we were riding the struggle bus, but it was way easier to make impact on target. We had better wind calls, truer wind calls, and we had better elevation correction when we were using that custom stuff, and it made a big difference.
I think the more you can drill down in that the drag model, or like with Hornady's Ford-off solver, they're also collecting a data. They have a database of information of that bullet fired over radar, figuring out what that bullet does at different Mach values. So you can start, I think the best way to explain this would be, you could start very basic and enter in a G1, and it's like you mentioned, probably going to get you everything you need for the majority of what you do. You can go into a G7, which is taking into account the shape differences and profile differences of the bullet. Go into a custom curve, which takes you into the actual bullet being fired over radar, just not out of your gun. You can go into a multi-BC, or you can go into a personal drag model, which is your gun, your bullet. I think more important than anything is if you're going to a match or going on a hunt or you're using it in line of duty, confirm your stuff, right? Go in and confirm, and when you're confirming BC, confirm it at a bunch of different distances.
Yeah, I think that's a really good tip. And then, probably goes without saying, but if you've got a rifle that's shooting 2 inches at 100 yards, maybe don't have the expectation of, long range accuracy. So get yourself an accurate rifle, or the rifle might be plenty accurate, but just, it might like a particular load more than heck, Ryan. We were doing that the other day with one of your rifles.
Yep.
Good old 6.5 Creedmoor, your go-to. We tried, I don't know, 2 or 3 different types of ammo through it, and it all shot good, but one shot great.
Yes.
So.
Yeah. Yeah, it's interesting to see G7, and maybe it's just my awareness of this kind of stuff, because I was not traditionally a long-range shooter at all. Like I said,
Same here.
Yeah, and then looking at the solvers that have come to light recently, within the past half decade or so, the advancement in that tool technology alone, and then what manufacturers are doing, listing both or listing only one. Like right now, this 127 LRX, you can only get the G1 data. And then lending to your expertise, would you say that fits a G1 drag model or a G7 drag model better?
Based on just the overall look of the bullet and that it does have a boat tail, the boat tail typically should be less than 1 caliber width or in length,
Sure.
right? It should be like 7 to 9 degrees. And so it looks to me like, I haven't looked at a cross section of that bullet,
Sure.
but it looks to me like you'd be more, you'd see better data if you use a G7.
Sure.
But also I think with some of, you look at a box of ammo and it'll say G1, G7, right? I think a lot of the times companies are doing that because maybe it correlates well with what it's intended for, but also, just you do need to true it. If you are going to go into any environment where hitting that target is critical, you should true it and look back at what was my actual results versus what did the calculator predict.
And Mark and I, we've seen that dozens of times when we've gone out and we've trued to a given distance. We're showing up either MV a few feet per second here and there. Are we trusting our chronograph? And then we range validate and we find that we actually have possibly a different velocity. And we've tweaked BC numbers so that they land better. Going back over that now, I wonder, would I have been better served plugging in a G7 figure instead of that G1 that it's published with? A lot of the calculators that I have used and still do use have, if I enter a G1 and then I switch the profile to a G7, as long as I have like the bullet length, weight, caliber, it gives me a figure in the G7 that's otherwise not published.
Right.
So maybe I should start with that different, start with that from the get-go. It's a fascinating thing. There's a lot of moving parts.
Yeah,
here.
and whether you do have the thing to keep in mind with all of this is that we're referring a bullet back to this standard, and you have them printed out, right, Mark? So you've got them printed out. Like, those are the 2 standards. That's a G1 and a G7. Unless a bullet exactly matches that profile, the numbers you get out of a calculator won't be exactly what it says it's going to be. You're going to have points where it crosses and hits a little high, and you're going to have points where it crosses that path or that curve and hits a little low. Yep. So I think the best, and listen to the guys at Hornady a lot about this with their Fordorf solver. They kind of take away from that by using the bullet's drag, not a ballistic coefficient, so the drag model, and then also looking at that personal drag model where you're getting your data from your gun. But unless the bullet exactly measures to those dimensions, which I would argue very, very few, if any, do, you'll get a little different numbers out of your solver. And it's kind of a matter of finding where it's close enough for what you need to do at a bunch of different distances.
Gotcha.
I have a hypothetical question. No, it's a real question. I'm going to ask it, but in a hypothetical situation. So I understand the limitations of my projectile from its design standpoint, like the distance at which it would work.
Right, for what you want to use it for.
Right. If I'm going to use that projectile within that window and not get into, and I'll use this 127 LRX specifically, right? I know that I need X velocity to get it to expand.
Yep.
And I know that window resides somewhere in the gun that I'm firing it, depending on where I'm at geographically, between about 600 and 700 yards. I will true to those distances, and like I want appreciable accuracy to about the 10th mil resolution, right? Do you think I'm up a creek without a paddle as a shooter, not using that G7?
If your data all lines up, then I think you should be fine. Again, it's as soon as you change other variables like like temperature and pressure and stuff like that, I think you might see some deviation from the numbers that you tested at.
Sure.
But as long as you're I think the big thing is like as long as we're inside of that transonic, you're probably going to have results that are what you want.
And that kind of was going to be my next question, right?
Yep.
So if you're shooting the high BC slippery profile bullet and the intent is long to, extremely long range,
yep,
that's where that G7 is really benefiting you to model after.
Absolutely.
Okay. Yep.
Cool, man. The BC rabbit hole runs a little deep.
Yeah.
Do you?
And you can get into the discussion if you should even use BC, or
Sure.
if it should be strictly multi-BC, or if it should be a function of drag, like the Fordhoff solver uses.
Right. Yeah, definitely a couple of different ways to skin the cat.
Right. And then argue about what is more better. And this is stuff we've talked about before. Have we become obsessed with the BC figure as a shooting community? And then you throw that wrench in there. Is that even the figure to be obsessed with?
So I mean, I will say, and you can say, I think anyone would be able to say like, oh, it's not that big of a difference. I can tell you that when we go to a match and Tucker's shooting the 110, 6mm 110 A-tips with a higher BC than the 108 ELDs that I'm shooting, a couple hundred feet per second velocity and a BC difference. Even if I'm pushing that 108 at the same velocity as those guys are, the wind call at 1,000 and beyond is appreciable.
Yeah.
Yes.
Yeah.
It is. And so that BC does help.
Mm-hmm.
That's fun.
The wind.
So all else equal, if you've got a bullet with a higher BC and you're trying to select whether it be a hunting bullet,
Yep.
Give it a shot and look at it and actually see what happens to you when you're out shooting in the field, when
Sure.
you're confirming your data. And it's interesting to take a look at. I'm trying to think of the specific example I just saw, but you see it a lot in like the long range hunting bullets, like the difference between, a 165 7mm bullet and like a 190 or something, like just a BC increase. Jacket construction, the same.
Yeah.
Bullet profile, relatively similar, but a much higher BC. It's the wind call at 1,000 changes significantly.
I always thought that bullet weight had like a hefty component as it related to like wind calls, but it sounds like it's just more like it seemed to me like, oh, if I have a heavier high BC bullet, that would do better in the wind than like a lighter weight BC bullet because it'd be like harder to move.
I think it can, but there's a couple other things going into that mix as well, like cross section. So like,
Right.
yeah, I mean, if you have a sail
Yeah.
versus a small stone, one of them gets pushed, one of them doesn't. But then velocity as well.
Yeah, we were talking about this the other day with like a lead cup and core bullet versus a solid copper bullet.
Mm-hmm.
Remember when we were chatting about bullet selection? If you have one, that and typically you see this when people are going to like a Barnes LRX or a Hornady CX, and you look at that, right? What grain weight is this bullet?
127.
That's a 6.5.
Yep.
And that's a 140.
Yep.
ELD, right? So that lower density material is going to need to be bigger to have a higher BC, right? So you do see that longer, more material to get the same profile,
but
it's even less weight.
Yeah,
I think I said
they
that
still
right.
they still can't even match the BC of that 140 just as it sits, and they're remarkably similar in design, but they're miles apart from a BC figure.
Which, just like looking at them with the naked eye, they don't look too dissimilar.
No, they don't. It doesn't take away from my personal experience with the lower BC thing, because again, I'm not shooting it in the distances in which, not that I can't shoot it that far, but I just wouldn't, because the bullets are designed to do very different things. Yeah.
Well, you're looking at something, potentially from like, oh, this is my hunting perspective. Like you said, I know that, the max velocity threshold where it's going to expand properly versus we're talking, like you said, you're, beyond transonic, 1,400 yards.
Bullet selection is like another hour and a half conversation at least. But yeah, if it's performing what you need it to do within the distances you need it to to shoot and the bullet performs how you want it to, then let BC be what it is.
There you go.
Still important.
It's still important. The screen is turned black. MC Ryan's face is red with rage because we've gone way over time. No, he's not. He's always super mellow back there. But, gentlemen, thank you so much.
Yeah.
For, like I said, diving down the old BC rabbit hole.
I try and take things from I'm not an expert on ballistics. I soak some of it up in the being out in the world of shooting, but trying to put it from a layman's terms, what should you be doing? What should you be selecting?
There you have it. Well, hopefully we help some folks out there select the right BC for their applications, for the bullets that they're pushing through their rifles. And until next time, happy hunting and shooting. Catch you on the next one.
See ya.
Thanks, guys.